Hello everybody, and welcome to my first attempt at a screencast for how to better explain topics in AP Chemistry. This will lead to everyone passing the exam after this project. What you need to do is turn to page 8 in the packet that I gave you over break. So take a few seconds to turn to page 8. At the top, it should look at exercise 9, saying calculating equilibrium pressures number 2. If you need to, you can pause, and I'll continue right now. The question says, at a certain temperature, a 1 liter flask initially contained 0.298 moles of PCl3 and 8.70 times 10 to the negative third moles of PCl5. After the system had reached equilibrium, 2 times 10 to the negative third moles of chlorine gas was found in the flask. Gaseum PCl5 decomposes according to the reaction seen below. And we want to calculate the equilibrium concentrations of all species in the value of K. What we want to do here is look at the previous page where it says setting up a rice table. This rice table is going to be very important in doing these type of equations when you're giving initial concentrations and equilibrium concentrations, and you need to figure out eventually a value for the equilibrium constant K. So if you look at the previous page at RICE, that's what we're going to set up. R for the balanced reaction, I for the initial concentrations, C for the change, and E for equilibrium. One thing we're going to need to know for all of these is that each box that we set up has to be in molarity. So you're given moles here, and moles here, and moles here, but that's not molarity. We recall that molarity equals moles over liters. Simply enough, this problem gives us a good number, so we're looking at, if we look at the PCl3, it's going to be 0.298 moles over 1.00 liters, and we are looking at 0.298 molar. And we're going to use that value, and we're going to use the same values here and here as well on the next page. So, in your space, I'm going to open up a new page in the video, and what I want you to do is follow along. You might need another sheet of paper, or you could just follow along on exercise 9 below. Alright, so here's our reaction, and what we want to do is set up a rice table, and I actually left myself too little of room, so I'm going to, okay, PCl5, which is a gas, goes to PCl3 and Cl2. And here is my R for reaction. And I'm going to set up a table like this. Go down, I'm going to write I, C, and E. I again for initial. C is going to be your change, and E is going to be your equilibrium. In the example that I set up, I wrote numbers and circled them. So 1, 2, 3, 4, 5, and 6. And they're kind of all over the place. But I'll help explain them here and where I got them. Before that, I want to kind of set up this grid. If you see a double equilibrium arrow, give yourself a double line. If you see a plus sign, give yourself a single line. That will just help break it up easier. Alright, second thing, we want to put our concentrations, our molar concentrations, into the boxes where we are given them in the problem. So let's see here. If we go back, it says initially containing 0.298 moles of PCl3. So initially, that is going to be your letter I. So for PCl3, we're going to put 0.298 molar. You don't have to write the M every time. It should be assumed that it is molarity in there. Let's see if we were given any other initial information. Yes, 8.7 times 10 to the negative third molarity for PCl5. So 8.7 times 10 to the negative third, excuse my sig figs there. And let's see if we were given any other information. After the system had reached equilibrium, we had 2.00 times 10 to the negative third molarity for chlorine. So let's put that in there. And it said equilibrium. So I'm not looking at I here. I'm looking not at C, but I'm looking at E. So this, if we want to rewrite it not in scientific notation, will be 0.002. And so as you can see, this I wrote a number 1 here, I wrote a 1 here, and I wrote a 1 here. I'm going to undo that just so we can use a different color. And I'll use red for all the steps. Alright. Secondly, it doesn't tell us that we have any amount of chlorine gas either initially or at equilibrium. I'm sorry, either just initially. So if it doesn't give you an amount, we're just going to say that it is 0. Okay, so because there's no mention of the initial concentration, we're going to say that the initial concentration of Cl2 is 0. If you look at the third part that I had mentioned, the third part said that I plus C equals E. Alright, so then if I and C equal E, then 0 plus this value here must equal 0.002. And so this value is 0.002. Pause it and go back at any time if you need to go back through that. And so then this is number 3 here. Okay, an important thing that we are going to need to know big time in equilibrium problems is a ratio. The ratio of the balanced equation. And so a lot of the times I'm just going to write right below it this is a 1 to 1 to 1 ratio. Because the numbers in front of the balanced equation are ones. So 1 to 1 to 1 ratio. Now if it's all the same ratio, 1 to 1 to 1, the change should be the same for each one of them. So if this increased by 0.002, and it increased because products are always appearing, then this should also appear at 0.002. But at the same time, because reactants disappear, we want to say that it is decreasing by the same amount, 0.002. And so that is step 4 there. Okay, so again, now that we have these boxes filled in, we can figure out our E because we said I plus C equals E. So let's do that. So down below, I know that if I plug this into a calculator, 8.7 plus negative 0.002 gives me a certain value, and that value is going to be 0.002. 0.29667 molar. And similarly, if we do the same thing for the PCl3, 0.298 plus 0.002, that's an easy one, 0.300 molar. And that is your step 5 here. Okay, so now we have equilibrium concentrations for all of our species, for PCl5, PCl3, and Cl2. But that doesn't answer our question. Our question says calculate the equilibrium concentrations of all species. Okay, so we did that. And we want to find the value of K. So the next part we're going to do, and you need to fill in these values as well, is to solve for our K. So if I move to my next page, if you recall from earlier in the packet, KSP is equal to the concentration of the products raised to their coefficients over the concentration of the reactants raised to their coefficients, and in this case that's Cl2 times PCl3 divided by PCl5, all to the first power because of their coefficients. And all we have to do is plug in the values from our equilibrium boxes. So for Cl2, that was 0.002. For PCl3, that was 0.300. And for PCl5, it is 0.0067. And when we multiply and divide, we get a value of 8.96 times 10 to the negative second with no units. That's the best part about K, is that you don't have to worry about units. So 8.96 times 10 to the negative second is your K. Ooh, and if we want to, think about this, that our K here is less than 1, which is not good. Okay, we don't want to say it's not good, we want to say that it's thermodynamically unfavorable. And making one more connection then, if K is less than 1, then delta G is positive. And you saw a lot of those questions on your midterm. It is very important. One thing that I want to emphasize while I can now, KEGHS 10,000, greater, greater, less, less, greater. I only eat cheese from a grater. Yeah, anyway, so you can't use this as an explanation on your exams, but you should say and know that if K is less than 1 here, which is the opposite of this, then G has to be the opposite of this. And so these are just some connections between equilibrium and thermo, and all are important. This concludes exercise 9, calculating the equilibrium pressures, number 2. The next video that you can see works on a more difficult problem, which will be exercise 11, that I had crossed out and worked for you, because there we are using x's, and I'll explain what we have to do with those x's in the next one. Thanks for listening. Hope it helped. Email me if you have any questions. Goodbye.